My name is Catherine Wark. I'm an application manager with the UK team at BMGLABTECH. You're looking after UK and Ireland. I'm very happy today to be joined by Celine Legroff from Servier, who is a project leader there. She will be talking more about how BMG instruments are incorporated into their day-to-day automation and screening platforms. But I have a few minutes with you at the start. And as PHERAstar is one of the high-throughput screening readers that Celine and her team use, I will spend a few moments talking about the features of this instrument and some of the things that contribute to some of the data that Celine sees with the instrument. So the PHERAstars were designed with speed and sensitivity in mind. They cover all non-isotopic read technologies. So everything for the fluorescence, frets, barrettes, absorbance, H2F and TR-FRET, alpha technologies. All of our systems pretty much are automation friendly, especially the PHERAstar. We have barcode readers also inside to make this easier. And for things like cell-based assays and enzymatic assays, we feature things like injectors and incubation on the systems. So, as I said, designed for speed and sensitivity in mind. And we use dedicated read technologies. This really contributes to the performance of the instruments and also the speed of the readings that we can achieve. So it includes not only xenon flash lamp, we have spectrometer for absorbance. This is scanning full spectra in even under 1 second per well for measuring absorbance readouts. We have 4 detectors in the reader, 2 that are optimized for fluorescence and luminescence readouts and alpha, and 2 that are specifically for TRF and TR-FRET applications. Laser for alpha and a laser for TR-FRET applications available. So really, there's no requirement to compromise on read performance because we are using the right tools for the job in each case. So with respect to wavelength selection, we have spectrometer that can dial in wavelengths, but for fluorescence-based applications, we use optical module blocks. These have filters and dichroic mirrors inside. They are bar-coded. This really prevents errors when you're running routine assays every day. People are not using the wrong things. And because of the matched or the pairs of detectors we have, we can measure simultaneous dual emission. So PMT1 and 2 or 3 and 4 are combined together. And this makes frets, barrettes, and FP applications really gives us the fastest speeds that are available on the market for reading those technologies. Most systems or people that use plate readers will be familiar that you can optimize Z height or Z height in the well depending on the liquid volume. Something more unique to BMG is that we can do this both from the top side and from the bottom side. This is often something you only see from the top side with most instruments. And the bottom read focusing capability really lends itself to cell-based assays. So when you are measuring cell monolayers, for example, we can focus up to where the cells are. And also we have different modes of reading non-homogeneous samples. So we can rapidly read with averaging methods, or we can even get kind of a heat map distribution of the signal across the well. So whilst we're not imaging the plate, we are getting a really good idea of the signal distribution across the plate. For those enzyme assays, we have the injectors. So users can have up to 2 injectors on the PHERAstar. And they are incorporated into the side of the instrument, so it does not change the footprint. Again, this is an important feature for automation platforms and also for just bench space in general. This is actually, Celine also uses PHERAstar in her laboratory. This is PHERAstar injection system. It works the same between PHERAstar and PHERAstar. We have very flexible volume choice when using our injection systems. So minimum 1 microliter injection volumes, changeable in 0.5 microliter increments. This is industry-leading specifications for injection. And we can inject and read simultaneously for fluorescence and luminescence, and even capture rapid kinetics up to 100 times per well. So it makes it very accessible for even sort of low resolution stop flow type applications. So most of the features I've covered so far, if somebody already has a PHERAstar FS in their laboratory, the FS and the FSX exhibit a lot of those points I already mentioned. But when we brought out the FSX, it really stepped things forward a little bit. So just to bring the specific points related to the FSX here is we saw sensitivity gains with all applications. We introduced things like alphaplex, reading 2 alpha screens simultaneously with this platform. We increased the dynamic range for luminescence as well, so 9 orders. We went from 2 million counts per second to 10 million counts per second. And we brought in new laser system for TR-FRET as well. So with the FSX, we really refreshed this instrument and added to its functionality and capability to tackle all assays. With respect to outstanding performance on the system, HRF is often cited with the PHERAstars. We have dedicated red-shifted photon counting detectors. Okay, with every flash you read, you accumulate more signal with this assay system. And we can either use the xenon flash lamp to excite this application. We have good performance in the UV with this system. Or we can use a dedicated TR-FRET laser. Now, the reason often people go for the laser is we get more energy with every flash of the laser. Okay, so more energy is supplied, and this gives us the fastest read times. We need fewer flashes with the laser compared to the flash lamp. Okay, this is one point. Of course, measuring on the FSX with the 60 Hertz laser compared to our 40 Hertz laser, users can choose to either keep the same read times as today with their FS reader and just have 50% more counts in the same time, or they can actually use, keep the same number of flashes of the laser and get faster speeds as a result of the system. In terms of performance level, the xenon flash lamp and the laser are pretty comparable. Look at these Z primes. It can be very much assay dependent as well as to the sensitivity benefits you're going to see. But with terbium, because the laser is exciting at 337 nanometers, we can often see an increase in the signal to blank. So in this case, with this terbium-based assay, we saw a 35% improvement. But this, again, as I said, could be assay dependent. The speed, and those of you doing 1536 well work, this is really the critical point for kinetics. When optimizing TRF and alpha applications, we have the ability, these are all time-resolved applications, we have the ability to visualize the decay curves live. So if you were doing assay development, you could run one plate, do a full decay curve, and really fully optimize with our integration wizard. One click of a button, you could say, please give me the best settings for giving me the best signal to blank or the best Z prime. So this tool really aids users, especially if you're making your own TR-FRET combinations or alpha screen setups. This is really an advanced way to quickly get the right settings to improve those signal for your assay. For luminescence assays, still we use a lot of glow reagents, and also alpha is in effect a very short-lived glow, but a glow assay. When we introduced the PHERAstar FSX, we improved our aperture system to make it more blocking, so you get less interference from crosstalk coming across the plate or from surrounding wells. So high to low samples are more clearly observed. But also there is a phenomenon with crosstalk where you can see light coming through the side of the microtiter plate. This is actually a white plate at the top with a torch behind. We think an opaque plate does not let the light through, but this is not really the case. And different plate types will exhibit problems or to a lesser or greater degree. So we have a wizard in the software which would allow us to understand the influence of the glow coming through the side of the plate and for us to be able to correct for that. So this would be indicative at the top of what blank wells were before they are reduced with our algorithms. So this can make a real difference also to users doing assay development. So my time is up now. Just to really summarize, the PHERAstar FSX as commonly used for people at the moment in screening departments, really suitable for all assays, even rapid kinetic assays using the injector system. Most sensitive systems still on the market today. The FSX specific benefits being the speed of the laser, the SDE for simultaneous dual emission for alpha, and increasing sensitivity for especially things like fluorescence polarization applications. So hopefully, if you don't already have PHERAstar in your laboratories, we've whetted your appetite to come and speak to us about it. But I will pass over to Celine, who can give us more of a real-life view of how to use these systems.
Thank you very much, Catherine, for this nice introduction, and thank you to BMGLABTECH to give me the opportunity of this talk. So I will present you the way we are using the BMG reader in the screening team. So my talk will be divided in three parts. First, I will present you the screening and banking team at Servier. I will present you our BMG readers and the family. And also I will present you three assay applications, three assays we optimize with the BMG readers. So first, who is the screening and banking team at Servier? So we've got a few missions. First is to develop the screening assays. We've performed HTS and HCS campaigns. We support the medchem follow-up, and we also centralize the storage and the delivery of compounds, cells, protein, and biologics. So we've got a quite central position in Servier, and Servier has a few multiple therapeutic areas, and we work for all of them. So we work on projects in oncology, neuropsychiatric disease, immunoinflammation, cardiovascular disease, and metabolic disease. So we have a wide range of therapeutic areas. So by consequence, we've got multiple targets we are working on. So we work on membrane proteins, GPCRs, cell phenotype, nuclear receptor, ion channel, soluble enzyme, intracellular proteins, transporter, secreted proteins, or any other target coming out of the head of the project manager in the company. So we've got multiple targets, so we got multiple technologies as well. Mainly, we are using fluorescence and luminescence with a large part of TRFRET and HTRF mainly, fluorescence intensity, luminescence, and fluorescence polarization. And for the HTS, we mainly use fluorescence and luminescence. That is very convenient for this kind of throughput, very high throughput. So we are central. We work for all therapeutic areas, and we work from the beginning of the project, from the assay development up to the medchem follow-up and the PCC. Each phase of a project got different activities, and especially the throughput of plates and the number of the compounds we screen is different. So in the early phase of the project, in the assay development phase, we developed the primary and secondary assays, and we also developed the automation of those assays, so it's kind of few plates a day. When we arrive at the screening part, so it's divided in three parts in our team. So the pilot screen that validates the primary screen, the primary assay, and also we validate the automation of the assay. We've got the primary screen, so we screen all the library, Servier's library, and we also run secondary assays. So it's those response in the primary screen, also counter screen and orthogonal assays. So we can parallelize lots of assays with a large number of compounds in those response curves. And finally, after we identify it, we work in close relationship with the chemist for the medchem follow-up. We screen on a weekly basis all compounds synthesized by the chemist team, and we can run up to 10 plates a week per assay. So as you can see, there is quite a large variation of the number of plates we work with all along the life of the project. So we need readers able to adapt from few plates a day up to hundreds of plates in a run in a day. So it's why we really appreciate to work with the BMG readers for this part. And I will present you now the way we use them. So we got a quite big family. We own 3 generations of PHERAstars. So we got the old one. We have a 15-year-old reader. It's still working, still in use. I've got a PhD student currently running a PhD experiment on this reader. We got PHERAstar FS and also the last one, the FSX. But we also own the ClarioStar that is mainly dedicated to the assay development or for the medium low throughput assays. And we also got an PHERAstar that is dedicated to the compound solubility assessment. And we integrate this reader to automate the solubility assessment. I will come back later on this part. So we use the reader on different modes. We got some readers that are on standalone mode connected with stickers that give us the opportunity to screen to put 50 plates in a sticker and to run the reader on its own. We use the reader for all activities, so for the assay development, but also for the full HTS campaign, for the semi-automated assays, especially the one we can use with multi-drops, and that gives us some flexibility, and we can use the robot for any different kind of assays in the same time. And we also got the ClarioStar in a standalone mode, and it's also used in addition of the basic function of the PHERAstar, it also used for the spectrum of the compounds. This is the kind of semi-automated assays we are running. So we start with assay-ready plate, we make all the dispense and incubation time, and finally, the final incubation and the reading is in the PHERAstar on a standalone mode, so someone else can use the multi-drops and running another assay. We also integrated the readers in a big robotic platform. This is our big one. And here you can see the PHERAstar FSX. It's included in a big system with echoes and incubators, plate lock, spin. And the interest is this reader is also, we can also use this reader on a standalone mode. When the platform is running but not using the PHERAstar, we can still using it for other application. We got a second PHERAstar FSX integrated in a smaller platform that is also centered on a robot arm and with multi-drops and incubators. And finally, we integrated the PHERAstar. That's an important step in the validation of our hits. And all the its candidates are validated for the solubility. And we integrate the PHERAstar here with a robot RAM and multi-drop that give us the opportunity to screen in 384 format up to 260 compounds a day. So I will now present you some applications. Some assays we develop in the lab. It's not only my assays, it's also my colleagues' one. So the first one I will present you is the optimization of an HTRF assay in a 1536 well format. So this assay, in this assay, we were looking for inhibitors of a protein-protein interaction. And we developed in partnership with SysBio an HTRF assay. So Shortly, so we were working on 2 proteins with PPI, and so each protein was labeled with tags, and we use antibody against each tag. And we co-incubate with small molecule, and when the smaller molecule interact with the protein 1, we lost the HTRF signal. So this assay was already working in 384 format, but we decided to transfer it in 1536 format using a robotic platform. And we work mainly on the reading mode we could use with the 1536 format, and also on the antibody dilution in this assay. So here I present you the HTRF ratio for 3 modes of reading and plate formats. So we compare the 384 format with 5 flashes compared to 1536 format, and the 1536 format with the flying mode. That is the most efficient reading mode on the PHERAstar. And as you can see, there is no major difference in the minimum and maximum signal for each condition. And if we compare the ratio between the basal signal and the maximum signal, we don't have any difference in the ratio. Just a slight decrease when we move for the 1536 format in a flying mode, but nothing significant, as we were over 15 as a ratio. So we have the luxury to lose slightly a signal. So there is just a slight decrease, but definitely no difference between the 5 flashes mode between 384 and 1636. But using the flying mode make a major improvement on the time we spend to read the plates. So for a 1536 plate with 5 flash, it takes 3 minutes and 50 seconds to read a plate. And when we move for the flying mode, we went below 1 minute. So using the flying mode combined with the 1536, we increased a lot the throughput of the assay on the platform. And the time for reading a plate was no more a limiting step in the robotic process. The other things we work on for this project was the antibody dilution. So we can play with the concentration of the antibody to decrease the quantity of antibody, so decrease the cost. But the idea is to keep the same signal. So I will present you only 2 dilutions of the antibody, but you can imagine we made lots of combination. And we also combine this with the reading mode, 5 flashes and flying mode. And for any dilution, so the dark or the light color versus the flying mode, there is no difference in resume. So, oops, sorry. So there is we were able to combine the flying mode and an higher dilution of the antibody using the sensitivity of the PHERAstar FSX. So on this assay, we were able to validate the 1536 format, and the flying mode was also validated, and we could dilute the antibody more than at the beginning. So this is due mainly to the high sensitivity of the FSX and the robustness of the assay that working together give very, very good results. And it represents a large cost reduction and a large gain of time, because screening of 1536 plates takes much less time than the 384 format. In this second assay, I will present you a quench assay miniaturization. So for this assay, we were working with the protein and its natural ligands. The protein was labeled with the cyanine 5, and we've got a quencher on the natural ligand of the protein. And we were also looking for inhibitors of the binding site. So when small molecules and inhibitor bind to the protein, the ligand couldn't bind anymore, so we we were losing the quench effect, and so we could follow monitor the fluorescence. So as the previous assay, this assay was already working in 384 format, and I will present you an optimization for the 1536 format, and also we compare different readers in this optimization. So here you've got the basal and the 100% inhibition signal, so the minimum and the maximum assay window. For the FSX with the two-plate format, we compare it also to the BMGLABTECH and another multimodal reader we got in the lab. And as you can see, there is a similar assay window between the two formats of the plate for the FSX, and the assay window was the same for the BMGLABTECH, but we've got a very small and very reduced assay window for the other reader of the lab. And it's mainly due to the lack of the sensitivity on the low signal. And if we if we analyze this data regarding the Z prime of the plate, in this other experiment, we also compare the 20 flash to 5 flashes with the FSX, the flying mode, and the reader X, still get the same. With the 20 flash flashes, we've got the best signal and the best Z prime, but it takes quite a long time. The flying mode was not working for this assay, but we were able also to reduce the number of flash. We could keep a good assay window anyway, and a good Z prime, sorry. And for the reader X, the conclusion was the same. We obtained negative Z prime, and it's mainly due to the lack of sensitivity for the low signal and the variability in the measurement. So in this assay, we finally used the PHERAstar FSX with 20 flash mode because 5 flash didn't give us. We had the time to use the 20 flash mode. It was not the limiting step, but we were able to miniaturize the assay in 1536 format. We tried the flying mode, but it was not compatible. That's not a big issue. And with the high sensitivity of the FSX, we had a major impact on this assay and for the throughput as well. And the conclusion is the same. We save money and we save time. And finally, I will present you a kinetic assay we developed on the BMGLABTECH. In this assay, we were monitoring the association and dissociation of a label ligand. So we were looking for the association of the ligand with an enzyme, and after we had an unlabeled compound to compete with the labeled compounds. So in this assay, we were monitoring association and dissociation, and we know there is a fast kinetics of association and dissociation of the compounds. So we used the BMGLABTECH with its injectors, and the key point was to capture the early time points of the association and dissociation. So this is the first experiment we ran. So here you got a range of concentration of the labeled ligands, and we monitor its binding, association along the time, and the dissociation. And as you can see, the main issue we've got at the beginning of the assay development, reading on a mode plate, full plate mode, was we were missing the early phase of the association. The time to fill the plate with the ligands, we were losing the 2 first minutes of the association. So we divide virtually the 384 plates into 4 blocks, and in place of reading and to dispensing and reading the plate from the beginning to the end, for each block we start to dispense the first up to the end, and the reading was starting on the same way. So we were reading we were working on one block after another one. And in collaboration with BMG France, we developed also a script to be able to reassociate the 4 blocks together and having only one file at the end of the experiment. So the virtual division of the plate in 4 blocks give us, in fact, the opportunity to catch the early phase of the association. The script was working very well, and this way we were able to analyze very easily all the data. So in conclusion, the combination of the injector and the flexibility and the sensitivity of the High-throughput allow us to monitor the fast kinetics, association, and also dissociation. The support of BMG was very important to develop the script and very helpful. In conclusion, High-throughput is sensitive, adaptable, and the BMG scientific support is very valuable for us. In conclusion of this talk, BMGLABTECH readers are highly valued in our organization and are central for the screening team at Servier. PHERAstar's readers are very sensitive, offering the possibility to adapt assays in the 1536 format, reducing region consumption and so the cost and the time. High-throughput flexibility and sensitivity make it the perfect reader for the assay development. And since we own FS and FSX reader, the sensitivity has never been a limitation in terms of assay development. And we got some very good interaction with BMG France that is highly valuable, and it's very key for a good and efficient assay development. So to finish, I will thank the screening and banking team at Servier, and especially Olivier Bruno, who ran the automation of all these assays, my colleague Anne Chast, Benjamin Chorion, Anne-Laure Hong, and Amaury Fernandez, who developed the assays I present you today, and also Pascal Nélon from BMG France. Thank you very much.